Hello. So up to this moment, we've been solving quadratics by factoring and by the taking of square roots. And now we're going to move on to something different. Okay. So now if you look at this one, okay, if I was gonna start by attempting to factor it, I might say what numbers multiply to give me -5, but add to give me +3. Well, if I look at that, okay, then that would mean, okay, numbers that multiply to give me -5. So 1 and 5. So -1 and 5 or 1 and -5. And that's basically it. So, and we know that if we add that, we get -1 plus 5 is 4. That's not +3. And 1 plus -5 is -4. That's not +3. So we can't factor it. And also, this equation, it has an x squared term, right? But it also has an x term. So we can't get the square term by itself to use the square root technique. So we're going to have to do something new. So in the previous video, okay, what we did was we derived this identity, that x plus a squared equals to x squared plus 2ax plus a squared, right? Okay. So in the previous video, we justified this expression. And so what I'm about to show you is how to complete the square, because we're going to be able to use this technique to solve this equation. Okay? So the way we're going to do that is as follows. We're going to imagine in our brain that we want to match this x squared plus 2ax with this x squared plus 3x. And you're going to see why we're doing this in a moment. So just to recap, what are we going to do? We're going to try and ask ourselves, what value of a will make x squared plus 2ax equal to x squared plus 3x? Aha. Well, what I can do is I can say, okay, in that case, 2a would have to equal 3, because then it would be x squared plus 3x, which is what we have there. And if I do that, then I can divide this side by 2. I can divide this side by 2, and I get that my a would have to be 3 over 2. Okay? Okay. So now let me show you how we're going to use this formula. Okay? So I now have my a is 3/2. My a is 3/2 because it'll make this first two terms identical to the first two terms of our equation here. Okay. So then I plug in here. X plus 3/2 squared equals to x squared plus 2 times 3/2 x plus 3/2 squared. Okay? And for 2 times 3/2, let me do that here on the side. So 2 times 3/2 is the same as 2 over 1 times 3/2, because we can write any number, any whole number like 2, 3, etc., as a fraction by setting it as the numerator and 1 as the denominator. So 2 is the same thing as 2 over 1. So now, how do I multiply fractions? I multiply them across. 2 times 3 is 6. 1 times 2 is 2. So I get this situation. And then I ask myself, what is 6 divided by 2? Aha, it's 3. So I can rewrite this right-hand side as x squared plus 3x. And now I'm going to calculate what is 3 over 2 squared. Okay? 3 over 2 squared is by definition 3 over 2 times 3 over 2. Okay? And then as we know, we multiply fractions by multiplying across, so 3 times 3 will be 9, and 2 times 2 will be 4. So I will end up getting that 3 over 2 squared is 9/4. So I can finally get that this over here is plus 9 over 4. Okay, okay. So now let me show you what we have just done here. I have just, look at this. This, by finding out what A had to be to make these two terms equal to these two terms, I now know that x plus 3 over 2 squared is equal to x squared plus 3x, which is exactly what we wanted, plus 9/4 in this case. Okay? So now, what I'm going to do is I'm going to get this piece by itself, this x squared plus 3x, by subtracting 9/4 to the other side. So it's going to equal to this, which is x plus 3 over 2 squared minus 9 over 4. Okay? So this relationship, which we proved in the previous video, which we derived in the previous video, allows us to rewrite this x squared plus 3x as this square term minus some constant. Okay? That is what we're now going to use to solve this problem. So now I'm going to replace x squared plus 3x in the original equation with this expression. Let me do that here. So this is exactly that. And then I'm going to subtract 5. And that's going to equal to 0. Okay? So now what has happened here is that I've transformed an equation that had an x squared term and an x term, which was going to prevent us from doing the square root technique, into an equation that has an x term that we can solve for it, that we can get by itself. But now we have this situation here. We have minus 9/4 minus 5. So I'm going to combine those first so I can put them on the other side, and then I'll be able to solve for the square root. So to move them to the other side, I'm going to have to add 9/4 to this side. I'm going to have to add 9/4 to this side. Then I'm going to have to add 5 to this side, add 5 to this side. Okay, and I'm going to put my line here. Now, briefly, over here, I'm going to calculate what is 9/4 plus 5. 9/4 plus 5 is the same thing as 9 over 4 plus 5 over 1. But they don't have the same denominator, so I'm going to multiply, in this case, this fraction by a fraction such that the bottom will, such that the denominators are going to be the same. Okay? In this case, I know that I can multiply 1 times 4 to get 4 on the bottom. But if I do that, I have to multiply the top by 4 also. Because a fraction with the same numerator and denominator is 1, and therefore by multiplying by this fraction, 5 over 1 times 4 over 4 will still represent the value 5, but will have a denominator of 4, which will permit us to add it to 9/4. So this will give us 9 plus 20 over 4. Okay? And this will finally simplify to 29 over 4. Because once I get the two denominators the same, I can just add the numerators. So now I know that this side, the right hand side, is going to be 29 over 4. And my left side is just going to be x plus 3 over 2 squared which is x plus 3 over 2 squared. And now from here, I can square root both sides. So I can say, okay, x plus 3 over 2 is going to equal to the plus minus. Remember, when we take the square root, we always affix a plus minus. The square root of 29 over 4. Okay? Now, there's a rule that says that if we square root a fraction of two numbers, and it's positive, then this will be the same as the square root of the numerator of the fraction divided by the square root of the denominator of the fraction. Or, to do it here, plus minus the square root of 29 over the square root of 4, but the square root of 4 is 2. Okay? So now, basically, we're almost done. So first, I'm going to set this equal to the positive version. So in other words, x plus 3 over 2 equals square root of 29 over 2. I'm going to subtract 3 halves. I'm going to subtract 3 halves to get the x by itself. And x is going to equal, they have the same denominator, so I can simply subtract the numerators. Square root of 29 minus 3 over 2. That's one of my roots. I'm going to summarize that here. X equals square root of 29 minus 3 over 2. Okay? And now I'm going to calculate my other root. How am I going to do that? I'm going to do that by setting this left-hand side, the x plus 3 square root of 2, equal to the negative square root of 29 over 2. I'm still going to have to subtract the 3 halves to the other side, so let's do that together. Minus 3 halves, minus 3 halves. And I get that x is going to equal to negative square root of 29 minus 3 over 2. And so that gives me, finally, my second solution as, here as negative square root of 29 minus 3, all of that over 2. Okay? Okay. So basically, the reason why we needed to learn how to solve a quadratic by taking the square root is because when you complete the square, what you end up with is you transform any quadratic into a quadratic that's in the square root form, the form that will permit us to perform the square root technique. And as we did before, what we had to do was we had to isolate the square root term first, then we square rooted both sides, keeping in mind always that when we take the square root of the number, we have to take the positive and negative square root. Then here, I showed you that if you take the square root of a fraction, it's the same as the square root of the top divided by the square root of the bottom. And then here, to finally finish that off, what we have to do to get the two individual solutions is that we set the left-hand side, the x plus 3 over 2, what was inside the square term, equal to the positive root, solve that for the x, and then we set it equal to the negative root, solve that for the x. And these are your two solutions. X equals to square root of 29 minus 3 over 2, and x equals to negative square root of 29 minus 3 over 2. That comma looks atrocious, oh my god. Okay, put a nice comma here, like this. Now, right now, I'm also going to solve the same equation using the quadratic formula, and then we're going to do some more examples with completing the square quadratic formula back and forth like this so that we can learn both techniques. I also want to tell you that yes, completing the square looks a little bit complicated, but if you watch the videos a few times, I'm confident that you will get the idea and be able to apply it. Thank you.